G'day, Jinx here, and welcome to tutorial 2 in my editing paletted graphics for Doom, specifically targeting MBF21 projects and Doom tools. And if you saw to the end of my last one, I mentioned that this was originally a great big long single session tutorial thing I did, and it was so long that I've cut it into sections. So it's basically going to start in a sec, and it's going to sort of start directly where the last one ended off. So if you're wondering why I'm mentioning things that aren't in the video, because they're in the last video. Okay, let's get into this. Now, just before we continue, I just do want to cover color maps quickly. Now, I'm going to be talking about color maps in greater detail later when I show you physically editing them and all that kind of stuff. But I just wanted to get all the sort of description of how colors work in Doom in one little section along with the palette stuff we just covered. Now, color maps are a kind of confusing thing. But the great thing about color maps is that a lot of the tools we have now allow you to ignore a lot of the technical information. But I do think it's important to know what is going on. So we're just going to cover the technical side, and you might go, well, that's very, very confusing. But later on in the video, I'm going to be editing some color maps and showing you how to actually physically change them and how it all works. And that's going to make a lot more sense. But first, you kind of, you need to know what it is, right? So what is a color map anyway? Let's load one up in Slade. This is the Doom 2 color map. And what we're looking at here is a 34 pixel in height and a 256 pixel in length image. And it is like the PlayPal. This is actually a representation of an index data structure inside the programming. There is no physical bitmap image inside Doom. If I go to Doom Wiki and go to PlayPal, they've actually got an indice map here that tells you exactly what's going on in the PlayPal. So this color here is color 0, and this color here is color 255. So in the color map, that entire palette from 0 to 255 is represented in a single line of pixels. Let's just ignore everything except the very top line of pixels, okay? So the pixel in the far top left is 0, and the pixel in the far top right, that sort of pinky colored pixel, is 255. I'm going to load this up in an image editor so it's a little bit clearer. So the way you can do that is if you click on the color map, you can just go right-click, graphic, export as PNG. So I've just loaded that up, that PNG export up in an image editor. And if I zoom in, you can see this pixel here, right? This pixel right here is actually index number 112. And it's 112 pixels from 0, which is this one here. So what I'm trying to say here in my complicated way is that that top line of pixels, right? Just that one line of pixels is the entire PAL 0, like what you're looking at now, just one pixel after the other. So pixel 0 is 0, pixel 1 is 1, pixel 2 is 2, blah, 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 blah. Pixel 112 is this green pixel. What's everything else in here? Basically, the way Doom renders things, lighting to fake this 3D look, it maps colors from one index value to another index value. If we look at the color map, there's two things we need to look at first. Firstly, the very last pixel line, so this is pixel line 34 or index line 33, this is ignored. This was originally used in the Doom demo, or maybe even in the beta, I'm not quite sure, but it's basically not used anymore, it's ignored. So even though the table itself still needs to be this correct size, as in 34 entries, the last entry is not used. Just ignore it completely. As far as I know, there is no way to utilize this. You can't put any data in here and actually use it in the engine as far as I know. The next one is also a special one. This sort of whitey looking thing that goes across the bottom. So if I go back to the Slade, you can see the big white one. That is what the screen turns into when you look at the invulnerability. If you just change this one line of pixels to another set of colors, the entire way invulnerability looks like in classic Doom will change. Everything else besides those two lines, line 0 to 31, is the light levels, which means that if you're in a darker spot where the light is lower, it physically changes the colors that you're seeing. If I go back to this green, this is row 0, which is full brightness. So that color there is literally the same color in our default play pal lump of pal 0 at index 112. But if we walk into a darker area, it's going to actually look at the table and say, we actually want to, whenever we are told to render index level 112, instead, we're going to render, say, index 124. And what that does, it changes the color. So remember, the color map and the play pal, it's not actually bitmap data. It's just these index values that relate to color values. So all the color map is saying if we are at this level of brightness, all the play pal colors are these colors here instead of the original colors in our palette. But the interesting thing is all the colors are still paletted. So while it can move one index color to another, it's like I could make it say if every time we go down, instead of going from 112, let's go to 251 and turn bright pink as it gets darker. I can do it. But the color that you're translating it to is still paletted. It still has to be part of the palette image. So what I'm trying to say here is that each horizontal line is the entire palette, one pixel after the other. But as you go down the light levels, it's the entire palette again, but with a different order of the colors. So in palette 0, 112 is a light green, but in palette 27, say, the color is a dark green. And it's done that by just changing the number. So remember when we loaded up the purple imp? So in the bitmap, the pixel is saying, I am color 112. But the color map is saying, whenever you see color 112, instead render color 124. And that's all the color map is. This is a visual representation of that reordering of the colors in the palette. And that's basically what's happening. There is no new colors being created. Every color in the color map has to be in your original PAL 0. All it's doing is saying, when you are looking at index 112, instead look at index whatever you've told it to. And that's visualized in the palette by these rows. As you go down these 31 levels for the lighting levels, it's just saying, okay, instead of using this color, use this color. Instead of using this color, use this color. And the practical way that's done in your image editor when you're creating these color maps is just to make a single pixel line of your entire palette, but just changing the color order by just changing the colors. Like I said, it's a little bit confusing, but you've got to remember that the tools we have now are pretty advanced, and you don't really need to worry too much about this stuff because there are a lot of tools that can convert RGB colors into index colors, which means that you can paint your levels in an organic way and then convert them into your palette colors. So by converting the RGB into a paletted image, you make sure every single color, no matter what you've painted for the, hues and lightness levels of it, will exist in the palette. And then when you import the image that you've created, the visual representation of the color map, the importing procedure will convert it into the data structure. So the practical way that I edit my color maps is that I just make a PAL 0 line for the very top one, and I just copy that line 31 pixels. So every single line is the full default play pal. And then I just use normal RGB painting tools like brushes, gradients, circular gradients, however you want to do it. And then the conversion process creates the correct paletted version of your color map and then creates the data structure that's used in the game. And then I just do some testing, just do it a bunch of times. So it's very organic. You just paint, convert, test. And so basically, you don't really need to know all this technical stuff. It's still a creative process. As long as the images on each line match your palette data, it's going to work. And like I said, once I show you some actual editing of the color map, it's going to make a lot more sense. But that is actually what's going on with ColourMaps. It's called the color map because it maps one color to another. But remember, it's actually only changing the index numbers. This thing here is just a visualization of what those index changes look like of the PAL 0 in the original Doom. The actual programming is just saying exchange one number for another. Exchange index 32, which is this one here, to index 47, which is this one here. So it doesn't matter. You don't really need to make your own color maps if, when you create your own palettes, you respect the kind of lightness to darkness ratios of the colors. Like I could change this whole color section here. I could change this whole color section to a pink to a dark pink, the pink to a purple, right? And this has changed all the colors in Doom, but in the color map, nothing's changed. It's still going to be saying replace 32 with 47 regardless. And that's why the Rad Soup palette and pretty much any palette that you plug in is still going to function, even if you don't create your own color map. But of course, if you create your color map based upon your own colors, it will definitely look better. And Slade even has some functions that can help you with the creation of your initial color map. So example, I'm just going to load up Slade. I'm going to create a new WAD, new archive, Doom WAD. So I just saved that as a WAD called demo.wad. I'm going to go into Neon Overdrive. I'm just going to copy the PlayPal into the demo WAD, but I'm not going to copy anything else. So this demo WAD that we just made is using the PlayPal from Neon Overdrive, but there's no new color map. So it's actually using the default untouched original Doom 2 color map. You can see that it's still functioning. Because remember, it's still working because it's actually only remapping the index values for the colors. It doesn't matter what the colors in the PlayPal lump actually are. But Slade has an ability to create a color map for you. So if you right click on the PlayPal and go palette, you can go generate color maps, boom, and it makes a color map for you. Now, I don't know exactly how Slade creates this color map, but I imagine it's some code that is looking at the color map from Doom compared to the PAL 0 from Doom and working out hue changes and chroma changes and, you know, stuff like that, and kind of approximating those changes to your palette and creating this. But you can see if we look at the Slade version of the color map that was created and we compare it to Neon Overdrive's one, you can see they're very different. Look how much smoother this pink graduation is here compared to these sort of brown steps and these gray steps here. Also, it's using the default invulnerability sphere. If you're making your own PlayPal, you might not even need to make a color map. And if you are making your own color map, a good place to start is just to use Slade's auto generation, and that gives you like a starting point. Anyway, when I get into the actual demonstration of editing stuff, we'll go into more detail about how to build these yourselves and stuff like that. Oh, and one last thing about color maps, because this is a very complicated WAD. This is a good example I can show you here. In the Boom generation of mods, so Boom, MBF, MBF21, etc., you can actually load custom color maps on the fly in your level via line def triggers. And a really common one is, say, like a blue map like this, and you have a fake floor, you drop into the sector, it turns blue, and it looks like you're now underwater. So there's a lot of really cool things you can do with color maps. It doesn't have to just be the primary, in inverted commas, color map, which shows the default lighting for the PAL 0. You can also basically map any color to any color. Whoa. Okay, that's the introduction. Now let's actually get started. Okay, so I'm going to cut the video there and we'll pick up in the next video from where we left off, just to shorten it a little. I've already explained a couple of times how the video just became ridiculously long. So yeah, the next one we're going to be talking about graphic apps. And I'll see you guys next time.